Okay, so we're gonna build a lap steel, and we're gonna model it after the Duesenbergs, which I believe are like the Cadillac of lap steels, and they are very high quality lap steels for a reason. One of those reasons is that it has a bender system where we can bend the G and the B string. I really like this Fairytale model, and you can see right away that this model has quite a bit of hardware on it, and that's one of the reasons why this is so expensive. Now, build that we're gonna do is just gonna be based off the Fairytale. We are going to get a bender system. It won't be this fancy, but we're going to try to find one that's reasonably priced. We're going to try to figure out what to do with the bridge. And essentially, the only thing we're really taking from the Duesenberg Fairytale is the outline, like the body, the shape of it. And you can see the shape is kind of very like Art Deco, and it's nearly symmetrical with the exception of the headstock. And that's what I like about it. And you can see that it's got this custom kind of capo nut. We're not going to do that. So we're not going to take any of the like fancy bits. We're just going to build a lap steel, just a plain old lap steel, but we are going to borrow the shape. The bender system is super awesome. This is the reason why I want to build a lap steel, and this reason alone. I've seen some YouTube videos online of some amazing musicians taking advantage of the bender system on lap steels. It's just gorgeous. You can't beat it. And that's the whole reason why we're doing this. So the specifications are all here, so we don't have to really think too hard, right? We know what the width at the nut is going to be. We know what the size is. We know what the string spacing is going to be. So we can even kind of like cop that from the website. And obviously the scale length is going to be 25.5. One of the kind of things I thought was always a little bit scary was, well, what strings do I put on there? What gauge? And it just right out tells you what to use. I've seen people go up to like a 60 on the low string, and that's something I might do as well. And I've also seen people take that G and B string and swap them out with like high carbon steel strings because you're bending so much. So the body shape is something we're going to totally steal. So the way this kind of goes out, kind of like a rocket ship, right? With the little tail end, all this is what we're going to copy. We're going to do a single pickup, and the placement of the pickup right now in my design phase is not important, but it's probably going to be a P90 somewhere in here. And it all really depends on where we place the bender system and the bridge. The Duesenberg has an integrated system, and we're not going to do that. We're going to use off-the-shelf products to kind of like cobble it together. We will have a volume knob and a tone knob, but there will be no switch. It'll just be a single pickup. The fretboard's really interesting because since we're not putting our fingers on the fretboard, we can use any material. So we have that wide open. We can use, rich light. We can use acrylic. We can use metal. It doesn't matter. The only thing that matters is that we have those fret marker and like fret guide placements. And we can do that on the laser. We can like engrave or we can etch on any kind of material. So that is wide open too. Do we want to do something that's kind of different, or do we want to stick with wood? And these are all questions we can ask later, but the next step is just basically outlining the shape. That's what we're going to do. And you'll notice it's got this kind of faux binding on here. So they kind of taped off the edge before they painted. I think that looks fabulous, and we'll probably do something like that. They even have like a faux truss rod cover. So obviously these lap steels are super thick. They don't require truss rods, but it still has this cover on there that just ties everything in together. So when you look at that headstock, you think, well, that looks like a guitar. It looks like a musical instrument I'm used to looking at like every day. And I love that. Okay, so I've traced out the actual Duesenberg Fairytale. I have the outline of the entire body, as well as the placement for the fretboard and my center line. So this is a really great foundation to start working on my lap steel. This means I can get a stock of wood, I can put it on the CNC table, and I can start kind of milling. Let's see how we got to this point. Okay, so here we have the outline of the Duesenberg Fairytale. Pretty simple to do. Really what I do is I just make a center line, and then I make one side of it and then mirror it to the other side, so we get that symmetrical look that we're looking for, and we don't have to build everything twice. In this case, I've mapped out where the fretboard needs to be. The cool thing about this is that I can kind of slide it up and down, and I can even move my bridge position and kind of play around with it to kind of find where I need those benders to be and where I need that bridge to be. There's a lot of space up here by the nut, so I have plenty of room to kind of play around with. So I could use a humbucker, but I've decided to do a P90. I've done these routes before. They're perfect, so I know they're going to work. I have a P90 laying around the house. I still can slide this P90 up and down the center line to put it wherever I need to. I'm not at that point yet because I don't know where the bridge and the benders are going to go. The control cavity is going to be pretty simple. I'm going to have two knobs, a volume and a tone, and there will be no switch because there'll be one pickup. and the jack will go back here, just going straight into the control cavity. It just makes more sense that way. So one of the clever design things I did was I positioned the control cavity to overlap with the P90. And this is by design. When we are building our pickup routes, we have to make a channel from the pickup route to the control cavity. And if I overlap them like this, then I don't have to. There'll be a sliver of exposed negative space where I can slide the wire through. I thought this was really clever, and I'll show you that once we get to the 3D model. But this is going to be essentially my starting point, the kind of foundation of the lap steel itself. I already have the placement for the frets, so these frets are on the fretboard, and I can slide this fretboard wherever I want to. You'll notice that the termination of the scale length from the nut to the end of the strings here, so the saddles or the bridge would have to go right here. And now I can scooch this up. I have some wiggle room up here by the nut to determine where I need to place this. And again, the placement isn't terribly important. What's important is getting the benders and the bridge system to fit, and I have quite a bit of space here. All right, so here is the model of the lap steel. This is essentially just copying the Duesenberg 100%. So this is the way it's situated when it's on your lap. So when I was building the inlays, I thought, well, let's put the inlays at the top, which is really at the bottom if you were looking at this from a guitar point of view. But from a lap steel point of view, if you're looking down on your lap, this is really where the inlay should go. Here is that kind of clever route I was telling you about. So in this case, it's a P90, and I've overlapped the control panel so that the control panel kind of goes into the pickup route. And what this does is it gives me a little exposed area where I can fit my wires through. I thought this was clever. That means it negates the whole purpose of a wire channel for your pickup route. That means it's 100% done on the CNC, no drills afterwards. And because it's a P90, it's not like a humbucker where the screws are at the very tips of the wings. It's a P90, so the screws for mounting are somewhere closer to the middle than the edge, like a humbucker. So I thought this was really cool. Where I deviated from the Duesenberg design was the placement of the jack. So in this case, instead of putting it at the center like they did to keep everything symmetrical, I just offset it off to the wing. That way it's actually going straight into the control cavity. I thought this was way more efficient. And we'll use some kind of really nice exotic wood or acrylic or aluminum to make the control cavity cover. One of the things that kind of bothered me about the Duesenberg was it doesn't have an volute. It just kind of quickly transitions into the headstock. And I know that you don't need a volute. It just looked weird. The Duesenberg looked a little bit odd. So what I did was I designed a very over-engineered volute. It's not really a volute. It's just adding meat to that section of the headstock where it would be kind of weak. So if you were to think about it, the Duesenberg follows this line here and follows this curve and then goes up to the main portion of the body. And this is just really too thin for my liking. So I wanted a little bit more meat. I thought, let's play with it. So my only worry is that these last tuners here might be impacted a little bit by that volute. But as I zoom in, it's not that bad. And if we needed to sand a little bit of this curved area to let that fit, we will. But I think we're going to be good. I'm not worried about that. A little bit of sandpaper and we're going to be fine. I also have a nice chamfer so that we can do the faux wood binding, just like the Duesenberg. So we'll tape all this portion off, tape the top off, and we'll have this cool binding if we want to. And I think the only way I'm going to get around to doing the binding is if I spray it, right? I'm not going to be able to get this if I stain it. And we'll figure that out when we get to that point. Remember, this is kind of a layered lap steel, just like the Duesenberg. So we have like 3 layers. We have the wings here. They transition into a nice, beautiful curve to the top section where the routes are. And then we have the actual fretboard. The thickness of the fretboard is going to be variable, right? I don't know what I'm going to use. Am I going to use wood? Am I going to use acrylic? Metal? Who knows? In any case, it's just a mock-up. I don't know what I'm going to be using, but if it was wood, I will determine the height of that wood based on what we decide to do with the bridge and the nut. Once I get that hardware in place, then we can figure out how high this fretboard or how low it needs to be. All right, so let's go ahead and go check out the wood. All right, so this is the wood that I've chosen for the lap steel project. It's a piece of alder and it's a very light alder. It's also pretty resonant. It's about less than 2 inches thick, so I measured around 50 millimeters, and it's quite long. So I only think I need a piece about this big, which gives me at least 2 feet or a little bit more of extra material to use to add as wings if I need that. But I don't think so. I think this is the exact width that I need for the lap steel. This is the same wood that I used on the MIDI guitar build. So the MIDI guitar was a neck through. It had a mahogany neck with this alder as the wings. Very light, very resonant, and it looks pretty good too. So this is the wood we're gonna use. We're gonna measure it out, cut off what we don't need, and then we're gonna put this on the table. And here's the thing about the table. This lap steel is so long, it doesn't fit on the CNC table. And what I'm gonna have to do is take it and put it at an angle, which does give me the right fit, which means I have to do some finagling in the software to get this diagonally at 45 degrees so that it can cut the whole thing. But that's something we'll talk about later once we put this on the table. That's really cool about these type of builds. Typically, when I'm building a guitar, I'm completely done in the design phase. I know exactly what I want from start to finish and I can just build it. This is kind of a cool, a little quick project that might take me, a week or two. So I can make these kind of decisions on the fly. That's what we're gonna do. Okay, so I've already rendered the wood. The specs for the Duesenberg had it at 1.65 inches thick. This was close to 2 inches, so I planed it down. You don't need to see that, I just planed it. And I do actually need to add wings. So the Duesenberg actually extends just a tiny bit beyond the width of this main board. So I cut off the length. So this is what we have here, which is essentially 960 millimeters. And I'm gonna glue these wings on like that. So I've already planed them and I've already jointed the joints. So all these are jointed smooth. And I only joint this board up to where I need it. So this is all jointed here and it's rough sawn over there. And the same thing here, it's jointed here and then rough sawn there. Basically I have 3 clamps. I put 2 on the bottom and I use a shelf. This is a known flat surface. And then I just use wax paper. And I have my 3 pieces of wood here. I've marked off where they need to be. And then the 3rd clamp will go on top. So all I need to do now is add some glue and just clamp it all together. Now, I know because this is a shelf and a known flat surface that the bottom seams are going to be perfectly even and there will be no lips. It's okay. There's a top lip here and here because the CNC is going to eat through this section no matter what. So the wings are actually situated lower than the main section here. So it'll ramp down and then chew through the wings. So all of this will be taken away. All right, so this is clamped up, nice and tight. The bottom we know is gonna be perfect. If there's a little bit of a lip on the top, that's perfectly okay because the CNC is gonna chew through that. Now all we need to do is let this dry overnight. And then what we'll do is we'll mark everything up so we'll know exactly where the lap steel sits in here. We'll draw a center line and then we'll draw the center point and then we'll mount it on the table. All right, that's all we got. Thanks for watching. Take it easy.